Welcome everyone to problem number 9 of the chaotic review. In this video we're going to suppose a particle has a given velocity, which is given by this f of t. So I have f of x. Let's go ahead and write down f of t. And that's going to be just everywhere I see an x, I'm going to write a t. So this is going to be t squared plus 2t minus 3. So there's our f of t, and that's velocity. So in fact, maybe let me even write it just as v of t, right? To really indicate that this is my velocity function here. All right, given this velocity function, we want to find three things. First of all, when is the particle standing still? How far does the particle move between t equals 0 and t equals 4? And what is the acceleration of the particle when t equals 13? So I have three things that I want to solve. We can think of this is really maybe belongs to the section like 2.7, right? We did a lot of this in 2.7. That was rates of change. So I would actually indicate this is 2.7, this is 2.7. But one thing that we didn't do in 2.7 is if given a velocity function, how far does the particle travel, right? So this is total distance traveled. This actually came up in 4.4. We talked a little bit about total distance traveled. So this is truly a hybrid, right, of 2.7 and 4.4. It's chaotic, right? It's a little bit of everything sort of deal. So let's go ahead and try to solve these three problems. Starting with A, right, these ones usually have a bit of interpretation to them. When is the particle standing still? So we need to remember standing still is one of these code words. It means that the velocity is equal to 0, right? So if the velocity is equal to 0, it's standing still. So I'm going to try to set my velocity equal to 0, and I'm going to solve, right? So 2t minus 3. So in this case, I think I can go ahead and factor this. So hopefully t, let's see, plus 3 and t minus 1. Double check if I was to FOIL that all out. Would I get back to where I started? Yep, seems reasonable. So this indicates when t is equal to negative 3 and when t is equal to 1, right, the particle is standing still. Now in this case I didn't specify, but quite often for these problems you sometimes see an indicator, right, saying like t should be greater than or equal to 0. So maybe if this was noted up here, then we would only choose the answer t equals 1. Right? So if it indicates somewhere in the problem that you only want positive time, which is reasonable, right, you only choose the positive answer. So that would be t equals 1 in this case. All right, for part B, right, how far did the particle travel between t equals 0 and t equals 4? So remember, total distance traveled, again, it was brought up in 4.4. This was the integral from a to b of the absolute value of v of t dt. So in our case, right, it specifies between 0 and 4. And I want the absolute value, and I know my v of t is t squared plus 2t minus 3, all inside of that absolute value dt. Okay, so now we need to remember, how do I evaluate out an absolute value integral, right? And so the steps that we take for this, right, is we figure out usually when is the thing inside of that absolute value equal to 0. And in fact, that was part A, right? We see at negative 3 and at 1, the thing inside of the absolute value is equal to 0. So we see mainly on our interval from 0 to 4, we have at t equals 1. This we use to go ahead and we split up this interval, right? From 0 to 4, we go from 0 to 1 of t squared plus 2t minus 3. And then we go from 1 to 4 of t squared plus 2t minus 3. So we want to evaluate out these integrals right here, and then we're going to take the absolute value of those and add them together. So that's the technique for evaluating out one of these absolute value integrals. So let's go ahead and evaluate this. So I'm going to have, let's see, 1/3 t cubed plus t squared minus 3t, and this we need to evaluate from 0 to 1. And likewise, when I evaluate this, it's going to be the same antiderivative, 1/3 t cubed plus t squared minus 3t, but now we're evaluating from 1 to 4. When I plug in 1, right, I'm going to have, let's see, 1/3 plus 1 minus 3. So let's go ahead and maybe actually pull off to the side really quick and simplify this down a little bit. So 1/3, let's see, minus 2. Minus 2 is the same thing as minus 6/3. So I'm going to have negative 5/3. So when I plug in 1, I get negative 5/3. So let me go ahead and substitute that in here. So negative 5/3. So that's what happens when I plug in 1. How about when I plug in 0? Well, I just get 0 in this case. So this is going to be minus 0. Okay, when I plug in 4, let me hold off on that 1 second. And then I'm going to plug in, right, I'm going to subtract away when I plug in 1. We already identified when I plug in 1, I get out negative 5/3. So I'm going to subtract away 5/3 here. All right, now let's plug in 4 and see what we get. So let's see, 4 cubed is going to be 64. So that's going to be 64/3 plus 16 minus 12. So again, kind of let's pull off to the side here really quick. So I'm going to have 64/3, and that's going to be plus 16 minus 12, that's going to be 4. 4 is the same thing as 12/3. Double check. All right, so that's going to give me, what, a total of 76/3 altogether when I add those together. So again, this right here is going to be 76/3. Okay, so that's how I can evaluate out each one of these pieces. So now in order to evaluate out this integral, right, I'm going to make each one of these positive, aka apply the absolute value. So let's do the absolute value of negative 5/3 plus the absolute value of, let's see, I'm going to have 76 minus 5/3. And oops, I made a mistake here, right? This should be minus a negative 5/3. So that should really be 76/3 plus 5/3. So that's going to be a total of 81/3 altogether. So negative 5/3 inside of the absolute value plus 81/3 inside of the absolute value. That's going to be 5/3 plus 27, right? Because that's 81/3 is 27. You can leave your final answer as this, or if you really want to, right, you can go ahead and simplify this down. We could add these together, and we would have 86/3. So again, the total distance traveled here would be 86/3. All right, finally, part C. So part C asks, what is the acceleration of the particle when t is equal to 13? So we need to know how to get from velocity to acceleration, and that's just given by the derivative. So when I take the derivative of velocity, remember I have the equation t squared plus 2t minus 3, I get 2t plus 2. So that's my acceleration equation. Remember, I'm taking the velocity here and taking its derivative. So I want to know, what is the acceleration at t equals 13? So that's going to be a of 13. So let's see, this is going to be 2 times 13 plus 2. So this is going to be 26 plus 2, so that's going to be equal to 28. Now again, I should go back and I should check for units here, right? Whenever there's units given to us, we should probably include those. So for instance, for my part A, we do have seconds, so we should say at t equals 1 seconds. But I don't seem to have a units for distance here, right? So I'm not sure if it's meters or feet or what's going on here. Let's probably pretend, I guess for a second, that it's feet, right? So the velocity is given maybe in feet per second. Just so that way, right, we say that the total distance traveled, that should be feet, right? So again, this is a distance traveled. And if the units are feet per second, right, then this is going to be 28 feet per second squared, right? So just in case if they have units, we want to make sure that we include those. Otherwise, you can get some points marked off. So that would be our units in this case. Of course, if they don't give us units, like technically I didn't give you units in this one right here, if you didn't include the units, that wouldn't be a big deal. But I think that this is a good point to kind of hit home in this review. So, all right, that's it for problem number 9. I'll see you guys out there.